Why are you not?
You started dragging the finger around.
All right. Okay. Guys, all right. Okay. Calculus.
Is that what we're in? Yes.
Let's start. Calculus. Okay. First of all, make sure everyone has a book. Everybody has a book?
This guy does.
I don't have a book.
I'll get it for you.
Okay.
Book.
I need to write a
One number
number.
13.
We're missing a book.
Okay.
I'm cold.
Books. Okay. All right. That's good. Thank you.
I don't even want it.
Yes? Huh?
I don't have any.
You don't have a book? Okay. I'll write it down. You don't have it.
Smells delicious.
Okay. Jane, I don't have a book.
Hit me up, please.
Okay. Okay. That's fine. I'll try to get one for you. Okay. All right. So, Alec, could you close the door?
Yeah.
Okay.
Look how serious.
Calculus. Actually, calculus is very easy because you already have done that. Everybody knows how to do calculus.
Everybody knows it.
Actually, every living creature knows how to do calculus. Because calculus is about motion and change. So when you throw a baseball, you are doing calculus. Your brain is doing it. Make that all the calculation for you, right? When you throw a ball. When you shoot an arrow, you do calculus. Remember, how do you shoot arrow to the longest distance? You have to shoot with a 45 degree angle. Why is 45 degree angle?
Calculus.
That's calculus. Well, but your brain knows. Your brain tells you how far you should shoot something. And when you walk, that's calculus. You are using your brain to move around.
We were saying this guy.
It should start it.
Yep.
Okay.
Nope, it's still
Good.
going. No, you're
All right.
good. You're fine.
So anyway, okay. So not even just tiny bugs knows how to calculus. We're trying to find something, how to fly to something, how to crawl to something. What actually amazing is those centipede, right? Have so many legs, and these can crawl. And it's actually very hard to do. But God has actually hardwired those creatures to do this. So calculus itself is not that hard. The hard part is how to read and write calculus. You know how to do it, but how do you read and write? It's kind of like a language. You know how to speak, but you have to learn read and write. So basically, this class is teach you how to read and write calculus. Okay. In terms of calculus, the most, I think, to me, like the best example is, remember Apollo 13. You guys watch Apollo 13? Well, they're not blew up. They are trying to get to the moon, but they're, I think the moon landing gear had a problem. And some fire up, caught fire and all that. So they cannot land in the moon. And so they have to come back. Remember, you probably saw this. That's famous. This is the Earth. This is the moon. Okay? The thing is already got to here. Now, in order to bring them back, two options. One is go this way. Okay. Do you know what's the problem here? You guys have learned physics last year. From here to here, what's the problem? What's the...
Take a lot of fuel.
Why is that?
Because you gotta turn around.
Yeah.
It's a shot.
They're losing all of their,
Huh?
they're reversing all of their momentum.
Right. They reverse their momentum. They are changing their direction. And for that, you take a lot more force. Then just keep going, right? If you keep going, actually, if you just If you just have the same speed, you don't need anything. You don't need any force. You just keep going. So they cannot do that. They calculate out they don't have enough fuel for them to burn to get back. So the only way they can get is go through.
The moon.
Go through the moon.
Do that. That's a slingshot. They actually slingshot the aircraft,
Gravity.
spacecraft, and put that off. Okay? Right? Remember that? How do you do that?
Calculus.
It's calculus. They have to calculate how because they have to change the trajectory a little bit in order to do that. They have to know how far away the change is. To hit right at the moment, this can slingshot it. Because if you go too close, what happens?
Land on the moon. Hit it. You die.
Yeah. Or if you get too far,
You die. You go into space.
go. You go there.
You get sucked.
You went to the wrong place. So there has to be exactly the velocity to get there, and use the moon's gravitational force to sling it. Okay, that has to be done in calculus. Okay, so I think this is a cool example. The calculus now, quite different from what you learned before, is that what you have learned in math before is all static, has no time element, right? So 2 plus 2 is 4, doesn't matter when. But when you're doing calculus, you put time into that. So things changes. Everything changes. So actually, in real life, nothing is still, right? Now we sit here, we think we are still, but we are not. What happened? What's happening right now? Huh?
Moving.
So, first of all, the Earth is
Evolving.
what?
Moving. Evolving. Rotating.
It's called rotating, right? By itself. It's called rotating.
Synonym.
And we do that every 24 hours. We finish the whole thing, right? As the Earth is rotating, Earth also do a, it's called E.
Equator. Rotation.
Huh?
Rotation. Evolution.
It's evolve, right?
Revolve.
Revolve, yeah. So they can spin like this and keep going like this. But that's not all. That's not all. Because our whole solar system has to do what?
Revolve.
Our galaxy is doing what?
Moving.
It's also revolving something else. So constant speed, okay? Actually, that's what reality is. And calculus is a tool, mathematical tool, to help us describe those kind of movements. Because think about this. When they're trying to shoot here, they have to consider what?
Gravity.
No, the Earth actually is moving. No, the moon is moving. It's not a single target, right? So they have to consider how the moon moves too. So that's what the calculus is. The most powerful tool to study motion and change. And also, calculus is called the language nature. So because nature changes always, nothing sits still. Everything changes. So stillness is just illusion. It's not real, right? We're moving. We feel like we are not moving, but that's just illusion. The real thing, reality is we are moving. Okay, so that's one thing. But God actually hardwired us to do those things. If God didn't hardwire us, we're in big trouble, right? We couldn't even move. We don't know how much force we should put on there. Sometimes we take for granted, right? Like when you move your feet, you have to control the force. You have to know that, right? Our brain is calculating. If something is wrong, we'll feel something not quite unpleasant. So have you ever trying to sit and find out the chair actually is lower than what you expect?
Yes.
Right? You're gonna feel it because your brain made that calculation, but it was not there. Okay, so if your brain calculated right, it just like it perceived wrong. It's not the height that the brain perceived. Okay, so we are hardwired to do that. So we can do those things. Okay, so so the part of the work actually we're going to do in this class is learn how to read and write, how to be able to use calculus to calculate, to figure out the movement, how things move, where it goes at what particular time. Okay, so that's one thing, that it's easy because we know how to do it. The second thing it is easy is because if we do it the right way, we have to change our mindset, how to look at things, because we are used to everything is the same, static. All the math you learn so far is static, does not change. So we have to change our mindset to look at things a different way. There are things in life. I would say there's two kinds of things in life are hard. Okay, there's the one kind things which are hard. I call it they are real hard, really hard stuff. Is, for example, playing piano. Can be very hard, right? Yeah, that's something I don't think if you want to spend 24 hours a day, I probably won't be able to do it. Or at least won't be good enough. Okay, and people will be annoying. Okay, like me. Those things are hard. Playing a violin is kind of hard, right? Even playing soccer, right? So I pretty much know everything about it, but I'm not really a good soccer player. Okay, those things are hard. You have to really put hard work. But there are other things which it looks hard is because you are doing not doing the right way. So for example, to put a nail through 2x4, is that hard or easy?
Hard.
Easy.
Easy.
If you have a bad hammer.
If you have a hammer, it is easy. But if all you have is a screwdriver, that can be very hard. So calculus is like that. The reason that people find calculus hard is because they are not being given the right tool. They are using the same tool as what you used before. When we're dealing with the math, which is static. Now we are doing math, which is dynamic, which is changing. Okay, so that's why another reason I say calculus is easy if you know the right tool. So that's something you're going to learn here. Okay, and I think another reason I say that is I have found over the 5 years I'm teaching that the difficulty people with calculus a lot of times is not calculus per se. A lot of times is because algebra. People have problems with algebra, so therefore they won't be able to understand calculus. Because calculus definitely use algebra as their language. We need to play with symbols to be able to get to the right calculation. Okay, so that's why I'm going to spend some time to go over that algebra. Make sure you guys are good with it. And this is also the reason I ask you to do the evaluation test. And I do say that a lot of you still have problem with it, which actually is college algebra is kind of like pre-cal. Actually, it's not as hard as pre-cal, because pre-cal prepare for calculus. So I can see you guys still have some problem there. So that's something we have to go over. You have to be very good at calculus before we can tackle algebra. No, you have to do algebra before you can tackle calculus. Once you understand algebra, then calculus will become easy. Okay? Right? So now we're going to start from our very beginning. Our very beginning deal with numbers. So remember what's the first set number? Huh?
Counting?
Counting number, first set. Okay, counting number. Second set. So, second set includes the first set. So all those sets
Zero.
always include, huh?
Plus 0.
Which is called what?
Whole numbers. Counting.
No. You don't count from 0.
Yeah.
That's called.
Programming.
Okay, what's next?
Integers.
Integer, perfect.
I knew there was 9.
Okay. Integers.
Rational.
Next one?
Rational.
Rational numbers. That's what we're dealing with. 1, 2, half, a quarter, those kind of things. Rational. So remember, rational number includes integers, right? Because any integer can be expressed as a ratio to integers. Like 3 can be written as 3 over 1 or 6 over 2, the ratio of 2 integers. So therefore, rational number includes all integers. So the set getting bigger and bigger always include the previous set. Okay. This is integer. Okay. So now we're going to see something happened, and that the first guy who discovered it actually got in trouble with it. He was actually killed, murdered, because of his discovery, because it didn't go well with. It didn't go well with the secret society back then. It's called Pythagorean.
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 Oh, Pythagorean?
Pythagorean society.
Oh.
He had this kind of like cult. And remember, I don't know if you see it. They put
Oh, the pentagram?
put that on their palm as their symbol.
Oh, just kidding. With the circle around it. Because remember,
No symbol, just that.
Never mind.
Just that.
I feel really
Okay. So when they actually meet secretly, they use this as their sign to identify each other. But the Pythagorean society has a very interesting idea about the universe. So, back then, Pythagoras himself was a philosopher. And back then, pretty much every philosopher knows how to do math. Okay, so he thinks that in the whole universe, rational numbers, that's all numbers. So everything in the universe is proportional. So all the numbers, that's all there is in the universe is rational numbers. So everything has a ratio. So it's called rational. Okay, everything in order. And that's actually the word came from. We call it rational. Some ways logical. They call it rational. Right? They have order to it. But the most famous theorem of Pythagoras is Pythagorean theorem. So Pythagoras theorem gives us this. Actually, if you say c squared equals to a squared and b squared, you are already talking about algebra. Pythagoras, back then they don't have algebra. They have geometry, but no algebra. So, and we know this, right? If this is 3, 4, this has to be 5. Okay? And this is right angle. Good. Now, what happens if this is 1, this is 1, this is square root of 2? Right? Right? So square root of 2 is a very interesting number. Square root of 2 cannot be expressed as a ratio of any integer. And that's quite irrational. But back then, they don't have calculator. How do they know this is an irrational number? How do you prove that it's an irrational number? Okay, that's what I'm going to do. Okay? So, in this class, I want you guys to learn how to prove things, because that's a skill you need. is in real life is how do you find the truth? The way to find the truth has to go through a logic thinking. So this is actually a very typical way of proving is by making assumption. You assume something is true, and then you got to the logic conclusion, and you look at the conclusion. If the conclusion is contradictory, then what happened to your assumption?
Wrong.
So your assumption is wrong, right? So what they to prove that, what we could do is we assume that. We assume this is true. Is P over Q. Now P and Q are integers, right? So assume that is a rational number, so I can express it like this. I don't know what P or Q are, but it doesn't matter in this case, right? We're just trying to say whether or not this is a rational number. So P is an integer. Both are integers. So that's a nice thing with algebra because it will just use symbols. Yes?
What if you have a rational number divided by a rational number?
You still get a rational number.
Okay.
Yeah.
That might have been a stupid question.
Yeah, like say, it's good question. Like say half over 3 over 2, right? So that's half times what? 2 over 3, which is,
So it's still just an integer over an integer.
yeah,
Okay. Never mind.
you always get to that part. Okay. But the good question though. So the ratio of rational number definitely is also rational number. Okay, so, but any rational number we can always simplify to the point that the only common factor is 1. Right? So you have 4 over 2, you got what? 2 over 1, right? Or 6 over 9, you got 2 over 3, right? So you always can simplify to the version that the only common factor is 1.
Simplify form.
Right? Right?
Yeah.
We can all do that, right?
All real numbers, right?
All rational numbers, not real numbers. All rational numbers.
Oh, 'cause you're rational numbers.
Right? All rational numbers can be simplified, right? To this point, right? Okay? So, if square root 2 is a rational number, we can always simplify to a ratio of 2 integers, but common factor is 1. Okay? Can we do that? Can we do that? That's assumption. Okay? We assume that it's a rational number, and we can always write that in the form of P over Q. P and Q are integers. And the common factor is 1. That means we get a simplified version. Okay? We good on that? So now what we're going to do is we are going to use logic step by step and to show that we got to a contradictory conclusion. So what we're going to do is we screwed, is this true? Based on that.
Yeah.
Right? Now, if this case, this is what? 2. This is, okay? If that's the case, what is P squared? Is what? 2 times Q squared, right? Right? So now P squared has 2 other factors, so therefore P squared is what? Even number, right?
How?
All even number has factor of 2.
Oh.
That's the definition of even number,
Yeah.
right?
Wait, what? You lost it.
From here to here, it's
2.
good.
Yep.
So I square on both sides because this is an equation, right?
Yep.
I can do that.
Yep.
Okay, I'm following all the laws of mathematics, right?
I just don't get how you got it.
From here to here.
Let's multiply that to every even number.
Oh, even number?
Yeah, how'd you get it even?
Well, because I multiply Q squared on both sides. So P squared is equal to 2 times Q squared.
What part of that is which part
2.
is even?
If you multiply any number by
This is an even number.
Because you can divide p squared by 2. It's an even number.
Okay.
So P squared is an even number, right?
Okay.
right? So a even number is a number which have two other factors. So that's definition. So p squared have two other factors, so this is an even number. And remember, we don't care about exactly what number is. We just care the property they have. We know this is even, right? But if p squared is even, what happens to p?
P is even too.
P has to be even.
Yeah.
Why is that?
Because if you multiply an odd number by itself, it always comes out as an odd number.
Great. So when you square odd number, you get odd number. When you square even number, you get even number, right? So p is what? Is even. So therefore, we can write p as 2 times n, right? Because p is an even number, right? And so the n is an integer. Remember, we don't care about the exact number. So this is a part of algebra, okay? We have abstraction. We are not talking about particular numbers. We are more interested in its property. Interest is an even number. Okay, now we have this. What happened to here? If we go back here, what we have? Okay. If we go back to this equation, p squared is equal to n. So 2n squared equal to 2 times q squared, right? And this is 4 times n squared equal to 2 times q squared, right? You good so far?
Yep.
Then we divide 2 on both sides. What we got q2 is what?
Where'd that n come from?
P equals 2 times n.
P is equal to 2 times n, plot back in here.
Yeah, where'd you get
The n is an integer.
N is an integer. Remember, it's just an integer. All we care about the property is an even number. Okay, that's the way we express it. So far, good. Is every step clear?
How do we know that it was Q or P that was even?
We know P is even
But
because P squared has to be even, right?
But how, because it has a factor of 2.
F factor 2
Squared equals 2 times P squared.
from
We
here.
divided it by 2. Where?
You mean here?
No. Oh, no, you
Which part?
divided it. It's just a factor of 2. Where?
P squared has a factor, has 2 other factor.
Okay, never mind.
Yeah.
I'm sorry.
That's good. Good question. So P squared is even, right? So therefore P has to be even, right? If P is even, we can write like this. We good here? Then we just plug back into here, this equation. We know this, right? Everything is logical. We follow the rule, okay? So plug back into here what we got? 2n squared, right? And that gives 4 times n squared, right? Now we divide by 2 on both sides. Our q squared is equal to 2 times n squared, right? So therefore q2 is an even number, right?
So Q is.
So therefore q has to be an even number too. So q has to be an even number. So now we got this interesting conclusion. Both p and q are even numbers. So therefore they have a common factor of 2. But we said we only had common factor 1. We get to the contradiction now. We get our conclusion is contradictory. So if our conclusion is contradictory, what happened to our assumption?
It is false.
The assumption here is false. So therefore, square root of 2 is not rational number.
Huh. That's interesting. Okay.
Right?
I like that.
Right? So that's kind of thinking I want you guys to have. This is a proof. This is actually the real math skill. Okay, you guys should know this, right? And you can have that go through the class. Yes.
But root 1 equals 2 over 2.
Which one?
Root 1
Root 1.
equals 2 over 2.
You mean
What?
Root 1 does not equal 2 over 2.
The root of 1 is 1.
Wait.
no? We said P and Q
Oh,
They can't
Okay.
be the same.
because remember we can any rational number we can always simplify until the only common factor is 1.
The common factor of 2 and 2 is 1.
P and Q. No, the common factor of 2 and 2 is 2.
You can find 2.
You also have common factor of 1.
I see.
Right? 2 over 2, both 2 has a common factor of 2.
So 2 over 2, why does
2 over 2 you can always simplify to this, 1 over 1. This is a simplified version. So we first assume square root of 2 is a rational number. If it's a rational number, we can always write as a ratio of 2 integers with a common factor of 1.
so 2 over 2 isn't rational?
2 over 2 is, but we can simplify it. This P and Q, we're talking about this.
So P and Q is the reduced version.
Yes.
It has to be reduced first.
Yeah, we have to go to the reduced version. Right?
Okay.
Because that's where we find the contradictory.
Okay.
We have to reduce that to the simplified version.
And then,
Then we follow the logic steps.
okay.
And we find that we get to the wrong conclusion. Because we start with common factor is 1. The only common factor is 1.
But only once you reduce.
Huh? Yeah. That's only when you reduce it. So this is a reduced version already.
Okay.
So that's how our assumption starts. Square root of 2 is a rational number as simplified to a common factor is 1. Because any rational number can write to this form, can reduce to this form. So this is reduced to that form, right?
Okay.
So we didn't change anything. We just still said this is come from a rational number, but we put a qualifier there that the common factor is 1. And so this part itself is okay. Right? We can do this. Just like we can reduce the rational number into this kind of simplified version. So that's our assumption. But with that assumption, we end up with something contradictory.
Okay.
Because we said P has to be even, Q has to be even. So therefore, P and Q have a common factor of 2. You definitely have a common factor of 1, but you also have a common factor of 2.
Okay.
So that's a problem.
I see.
But we started with 1, right? So that's one of, this is one of the basic proving techniques in mathematics, is by assume something is true, then you get to the logic conclusion and find that it's contradictory. Then that means our assumption is wrong. And the same skill you can apply to life. Sometimes if you don't know something is true or false, you can do that. Assume it's true, then you get back to prove it. Okay? But this can only prove something which is not true. It cannot prove something which is true. You got that one? Huh?
That's not
Because if it's true, you won't get contradiction. So therefore, you don't prove anything. So this kind of technique only proves something is false. So if you suspect something is false, you assume it's right. You assume it's true. Then you get work to its logic conclusion. And based on your conclusion you have, if it's contradictory, then you know your assumption is false. Okay, we good on this one? Yeah, you probably have to get some used to it, but I hope that as I give more examples, you get more used to how to prove things, because that's really the skill I want you guys to have. You can forget everything else about calculus, but the skills I want you to learn. Remember that, right? So people don't pay you for your knowledge. People pay you for your skills. They want you to have the skills. And you can see that, even though we're talking about math, we can use the same technique in real life, right? So anything, if you want to find something is not true, this is one way of doing it. But of course, there are many other ways you can do it. But this is a very popular and very basic mathematical method of proving. Okay, well, good. So far? Okay, so I guess I'm silent now. Right. There is one thing I like to do. I know that probably quite a few of you don't have daily devotional, right? Because if your fifth period is study hall, you probably don't have it. So I want to do that here. You guys okay with it? Okay. All right. So if you guys want to lead the devotional, that's great. And otherwise, I'll just use Oswald Chambers that my outermost to his highest. That book.
What is it called?
My outermost for his highest. I think.
Okay.
Yeah. You guys heard about that? Oswald Chambers? Huh? No? No? Oh. Yeah. Yeah. Okay. All right. Okay. We still have some few minutes. So, any questions? No questions? Anything? Don't have to be about math. You can ask anything. Talk about it. Well, time's up. Okay. All right. Because I will see you tomorrow. Okay. Yeah. So here's I like to go with you. I'm going to based on this. Okay, we're going to go over those problems together, and hopefully by doing that, we can have a good review of what you have learned last year. Okay.